Hello everyone, we are Meilta Unnesille team from Smart State University. First of all, energy is very crucial thing in our life. In Indonesia, energy uses in most sectors. As can be seen from the following graph is still dominated by fossil energy such as coal, gas, oil and so on, followed by electricity. But we need to know where the electrical energy comes from. In Indonesia on 2018, the largest producer of electrical energy was PLTU that utilized coal. As can be seen from the following graph, followed by gas, NRE, and fuel. Not only in Indonesia, even in Japan, the largest power plant is still a nuclear power plant that utilizes nuclear power. As you can see on the graph, out of the second largest energy source is electricity. It is still dominated by fossil energy, which is getting thinner day by day. With no alternative energy found, it is not impossible that Indonesia will experience an energy crisis. Based on data regarding the availability of fossil energy in Indonesia in 2016, it was found petroleum 11.6 years more, coal 67 years more, and natural gas is 41.6 years more. NRA as an alternative to generate electricity has been used in Indonesia, but still on a small scale. Examples of renewable energy used in Indonesia are water, wind, geothermal, solar panel, and this is because the use of NRA has certain terms and conditions that must be met. As with solar panels, to apply it requires a large and empty land so that it not block the sun's rays from hitting the surface of the solar panel as shown below. As we note that Indonesia has a water area of 62%, NRA that can be utilized from the sea such as tide, wave, thermal and pressure. Pressure is one of the major energy stores in the ocean, but this is still not widely explored and utilized. For that, we propose a tool that utilizes sea pressure called UDOM. UDOM stands for up and down molecule because of its molecular-like structure. It is a product of a deep-sea water pressure power plant combined with a building by utilizing a piezoelectric sensor that can convert pressure into electricity. The estimated electricity generated on UDOM is as follows. UDOM has a diameter of 3 meters, which means the surface area of the tool is 1,130,400 cm square. Divided according to the number of taps, which are 6 and produce 188,400 cm square for each tap, which means for each tap the pressure is 2,920,200 kg at the depth of 150 meters. Based on research conducted by UDOM in 2020, one sensor produces 1 volt. Then one tap containing 528,800 sensors arranged in parallel will produce a voltage of 0.5288 megavolts in one pressure. These are the components on the tube. They are tube umbrella that function to collect and receive pressure from seawater so that the pressure obtained will be greater than not using an umbrella tube. Piezoelectric as a pressure converter into electrical energy. The electrical energy produced will be channeled to the electrical appliance room. Other tube for piezoelectric housing and protection. When the tube umbrella is under pressure, the other tube will enter the inner tube. The spring serves to help restore the original shape of the piezoelectric when the pressure obtained begins to decrease. The inner tube as a piezoelectric holder and the entry of the other tube. And these are the components on the ball. There are the valve function to control the entry and exit of water or air into the ballast tank. The electrical appliance room functions as a place for converting and processing electricity obtained from piezoelectric. The final output will be delivered to the battery. The ballast tank functions as a reservoir for incoming water. The air compressor tank functions as a producer of high-pressure air which is useful for reducing the amount of water in the ballast tank. Because it carries the concept of a submarine, there are three conditions that occur in the core ball. The first is floating in the surface water condition when the ballast tank only contains air. Furthermore, there is a floating in the middle water condition when the ballast tank begins to fill with air through the lower valve and air exits through the upper valve. And the last condition is sinking. Here is a prototype of the UDOM Mark II consisting of an inner core ball, inner tube, piezoelectric sensor, outer tube, outer core ball, and tube umbrella. And this is a UDOM Mark II building that can store 4 UDOM Mark II balls. Here's how it works. So these are the advantages of using UDOM Mark II. From the advantage and logical calculation, it is hoped that UDOM Mark II can be implemented and commercialized in the future, so that Indonesia and even the whole world can use and experience electricity that comes from renewable energy without restriction, without polluting the environment, and without damaging the earth. Thanks for watching.